Let's see how to design a VRF HVAC system from the CAD drawings of a building and how to generate the thermal model of the building to calculate the thermal loads and obtain the energy rating. To get started, we open SIPE Architecture, which we will use to create a simplified model of the building. The application can be downloaded free of charge from the BIM Service Center store. We create a new file and save it to a path on our computer. When we click Accept, we have the option to link it to a BIM project or to create a new one. The BIM project is usually created in the architecture phase, and the rest of the facility systems are then connected to it. We enter the project name, in this case Offices BIM, and configure the type of project, the view options, and the management of collaboration requests. After accepting, the project name appears in bold in this box. We accept again. This is the work area. To move the view, we simply hold down the mouse wheel and drag the cursor. To orbit in 3D, we press the Shift key and drag. Let's go to the ground floor, which is shown by default, and activate the grid, which will allow us to work more comfortably. We can zoom in and out with the mouse wheel. In this case, we will use CAD templates to create a simple model. Windows Explorer opens and we select the templates. They consist of a ground floor and a roof. We then check the coordinate origin and the scale thereon. We make corrections if necessary. The origin is marked by dotted lines. In this case, we place it in the upper left corner of both. The lines don't appear yet because they must be assigned to each view. When we zoom out, we find that the template is too big, so we click on the DXF DWG template option again. Now, we select this tool to calculate the scale from a given reference measurement of the project, such as the door, which measures 1 meter. We take the calculated value, which will be proportional in X and Y, to apply it to our job. We now select the other template. There are no doors in this one. We assign the value of the scale in X and scale in Y and click Accept. We do this in both files because they are separate files. In this case, we aren't going to use the roof template, but we have added it to see what needs to be done when there are several floors. We zoom out and check that the scale is now correct. Now, let's create the roof floor at a height of 3 meters. By default, SIPE Architecture makes the cut at 1.5 meters, which is useful for viewing the doors and windows cut in half. The program distinguishes between views and levels, but in this case, we won't deal with that aspect, so we click Accept. Next, we assign the roof template to see how to proceed floor by floor. SIPE Architecture is an architectural program with a wide range of possibilities, but in this case, we will use it to create the geometric model. We access the Architecture tab to add, in this case, only the walls, floors, spaces, and roof. Although the program offers several possibilities, we are going to use it with the default types of external walls. Template object snaps can be activated, but this is not mandatory. We continue entering the lines. To finish entering them, just like in all the other programs from the store, we right-click the mouse. Let's move on to the internal partitions. The default wall type is a facade, so we are going to modify it. To do this, we unblock it using the padlock icon and click on the category drop-down menu. We can see that there is only one type of partition available by default and that we cannot create more from here. We select Internal Partition and modify its thickness. To draw them on the floor plan, this time we deactivate the feature for entering the known distance. Now, we have activated the snaps to the template lines, but what we want to do is to force the cursor to draw orthogonally. To do this, we use the option to force orthogonality using the Shift key, deactivate the template object snap, and continue with our entry. Next, we're going to add the floor slab. We check that it's correct in the 3D view. In order to calculate the thermal loads, it is very important that we enter the windows. We have a default type created called window. We place the first one. An arrow indicates where the outside is. We can align the window with the outer, middle, or inner edge in the adjustment section of the options panel. In the 3D view, we can see that the window is too high. We are going to place them all at 1.2 meters above the ground. We check that the model is correct in the 3D view. We add the rest of the windows. Once the windows have been entered, we select the roof floor to add the roof. Now we can see that there was no need to include the template, as the program shows the walls of the lower floor with a light grey line, so we can snap them. The next step is to enter the spaces. This part is very important for the subsequent calculation of the thermal loads and to obtain the energy rating. All the spaces have a name and a type. The default type is called default, but we can change this name later on. If we enter the wrong name, we can change it later from the properties panel of the space, and can even change other parameters such as the color or the text size, among others. In the 3D view, we can see that the spaces have been created correctly. The project should be saved on a regular basis. To enter a door, we must click 3 times. The first to set the position, the second to set which way the door will open, and the third to set the alignment with respect to the wall. We now have a simple geometrical model completed in just 10 minutes, which is enough to calculate thermal loads and then obtain the energy rating. However, the SIPE architecture tool has many other possibilities. It allows us to change colours and add textures, furniture, stairs, ramps, or trees, among other options. Whether we invest more time in making a more eye-catching model will depend on the type of project and the client. At the end of the video, we will see how this same model looks by adding furniture, colours, and textures. We are going to calculate the thermal loads of the building with the SIPE Therm Loads program, which is also integrated into the Open BIM workflow via BIM Server Center. SIPE Therm Loads reads the geometry of a building in BIM and allows us to choose the cladding materials, the interior and exterior design conditions, and to calculate the thermal loads. To get started, we create a new file and save it on our computer. Ideally, we save them all in the same project folder. One of the interesting points to note is that working in BIM doesn't mean sharing files in the cloud. What is shared is only the information that is entered into a geometrical model. Whenever we create a new file, the program offers us the option to connect to a BIM project. This time, we already have a BIM project, so we connect and mark the IFC file of the architecture to read the geometry of the building. This is the work area with the building read by the program. In the Analytical Model tab, we have tools for professionals with an expert level. In this case, we will focus on thermal loads. First, we click on Import the model, and in this case, we accept the pop-up window with the option marked by default. In the panel on the left-hand side, we can see that error signs have appeared. These are normal as they appear so that we can define the materials for each element. We start with the types of space. We define all the characteristics in the panel. Some cells are marked with a blue arrow, which allows us to access ASHRAE default values. This can be of great help when we don't know what the normal default values are. The program allows us to save element types that have already been created. This option is particularly useful when, for example, we are working with an architectural firm that produces certain types of cladding compositions. In this case, we are going to save the space type in the Materials Library folder and export it by clicking on the folder icon with the red arrow to be able to use it in future projects. When we accept the panel, we see that the warning sign disappears. We must go through all the elements until all the errors have disappeared. In the Facade External Wall panel, we can also define the facade layer by layer or import a previously created facade from a library. By clicking on the blue arrow, we can access the program's internal library, which is usually the ASHRAE library. In this case, we select an ASHRAE composition, but we are going to modify the thickness of the insulation. We can see that the value of the heat transfer coefficient and even the drawing of the layers have changed. We save the new type in the library. The doors do not have a library, but a common value for the heat transfer coefficient is 2. The same applies to windows. We will also set a value of 2. The program also allows us to define detailed values for shadows. To configure the thermal bridges, we select the Edges Processing option. Unless we are experts, we leave the default values. We now move on to the Thermal Loads tab. First of all, we access the Location Data option to configure the external conditions. If we do not know them, we can import them from the ASHRAE database. In Calculation options, we can define the safety factors. In order to create zones, first we go to Hypothesis, although generally we will only have one. We then create the zones. A zone is a set of spaces that will be heated or cooled simultaneously. Finally, we calculate the results with the Update Results option. If this bar graph appears, the results have been calculated correctly. By clicking on Complete Report, we can access the report or export it to PDF. The Share option allows us to upload the results of the thermal loads to the BIM model, which will be read by the programs it affects. In this case, OpenBIM Panasonic. Let's now move on to OpenBIM Panasonic. Once again, we create a new file and save it to a known location on our computer. To access the equipment library, we need to be registered and logged in to the OpenBIM database. Just as before, we select the BIM project. We can see that as well as the architecture, we have another thermal loads file. We select both of them. This way, we already have the geometry of the building as well as the thermal loads within the space panel. Now, we simply have to design the VRF system. We start designing the system by selecting the cassette icon. In the pop-up window, all the available models appear in order from the lowest to the highest thermal power. Before entering a cassette into the space, we must be in 2D mode and have already entered the displacement. Otherwise, the cassette could be accidentally placed on the ground. To carry out a design with cassettes, or other VRF elements in line with each other, we hold the next cassette to be entered over the one we have already entered for 1 second until a green cross is displayed, and we can then move it over the reference line to the desired location. HVAC systems are usually placed on the roof of the building, and we must select the appropriate view range to be able to see them. If the equipment is somewhat transparent, this may be because the cut of the plan is above the spaces. To correct this, we click on the current floor plan in the Views section and reduce the distance to the top plane. If we access the DXF DWG template option, we can see that the templates have also been imported together with the BIM model. We activate the Floor Zero template, as knowing the location of the furniture will allow us to place the equipment more accurately. If these object tracking green crosses do not appear, we should configure the object snaps correctly. All of them, except the last one, must be activated. Now we are going to draw the pipes. To do this, first we study the building to see where the vertical pipe will run to connect to the outdoor unit, which in this case will be on the roof. We select a utilities shaft and draw the first horizontal pipe from here. To finish a span, we right-click the mouse. Now we are going to place the outdoor unit on the roof and lower it right through the utilities shaft. There are several ways to connect the outdoor unit to the indoor system on the lower floor. One of the simplest is to increase the visibility range of the plan view using the distance to the bottom plane option. Simply set it to 1 or 2 meters. When connecting the pipe to the layout of the floor below, this rectangle must appear, indicating that the end has been snapped. This way, we ensure that the vertical pipe has also been generated, as when snapping between the pipes and the equipment, the necessary vertical spans are generated on their own. One way to check that the system has been connected correctly is by updating the results. This is followed by an automatic display of the error messages to guide us to the correct design. When hovering over the error sign, the window that appears shows that the load offered by this model is insufficient. Instead of modifying it manually, we can click on Sizing so that the program chooses the appropriate models for the thermal loads to be covered. We see that the warning signs in most spaces have disappeared. When some indoor unit models stop at one size despite not covering the load, it is because the outdoor unit has reached its limit. Effectively, we can see that the program has tried until it has reached model 10 of the 3-phase units. The program respects the series we have selected, in this case the Mini, so we change it and try again with the ECOI-EX. We now see that the program has even chosen a slightly larger outdoor unit from that range, and that warning signs appear on the spaces. Hovering the cursor over it shows that the signs are related to the refrigerant charge. To configure the calculation of the limit refrigerant charge, we click on General Options. Here, under Type of Building, we select Category C, which includes offices, to stop it from being calculated. By clicking on the Report option and selecting VRF in the pop-up window, the report containing all of the calculations opens, as well as the automatically generated schematic diagram, which can be exported as a PDF file. We can also generate drawings directly in PDF format, which, by default, includes a title block. This is the most convenient option if we do not want to lay out the drawings in Open BIM layout. In the Views section, we check all of the boxes. This process can take up to 2 or 3 minutes if it is a large building. The Drawing Layouts pop-up screen shows a preview. Clicking on Continue opens the Drawings window, from which we can now export the PDF with the drawings. Finally, with Share, we upload the information generated with the program to the BIM model in BIM Service Center so that it can be read, by example, by the Energy Simulation program. Now, we are going to generate the energy rating of the building and its facility systems with the Cyptherm HE Plus program. The program is in Spanish because it's used to apply the Spanish codes concerning the Energy Performance Certificate. Again, we create a new file, save it in a known location, and select the project on which we are working. The project with the most recent changes appears at the top of the list. The main program or starter program must be Cyptherm Loads, so we select Thermal Loads. In the Import BIM Models window, we check the boxes of the SYPE architecture and Open BIM Panasonic contributions to import the architecture and the systems respectively. The path of the saved building elements must also be checked. The dynamic of this program is very similar to that of the Thermal Loads program. We must go over the elements defining their characteristics. There are some elements, such as spaces or windows, that require a more detailed definition, as Cyptherm HE Plus is an energy simulation program that allows an hourly simulation throughout the year. Once the zone has been defined, the mechanical equipment drop-down list shows the devices read from the Panasonic program. By clicking on the Check the Model button, the program will indicate which parts of the project still need to be completed. When all the errors become yellow warning triangles, we then click on the Edges option to access the thermal bridges. We can see that the program has read the specific VRF models that we included in Open BIM Panasonic. In the Code Verification tab, we can generate the energy rating reports. Finally, we click on Share. On the BIM Service Center platform, we can see that all the 3D elements have been added to the project, as well as the PDFs of the results. However, the native files of each program remain on our personal computer. We can share and view the information generated with the program via the BIM Service Center platform, allowing us to access all the information from any device at any time.